Okay, we now have a hoodlum throwing a stone vertically downward from the top of a building, and the stone has an initial velocity, some initial velocity, which is, I'm going to say is less than 0 because we're throwing it downward. I'm going to define upward as positive y. And the stone starts some distance above the ground, which I'm going to call h, just because I feel like it. So, I don't know, the hoodlum is standing on the roof of a building, they say. So there we go. And there's our little hoodlum. You can tell how evil and hoodlummy he is. So, let's see, what's the question? How long does it take the stone to reach the ground, and what is the speed of the stone at impact? So, this is not terribly hard. Let's take a look at our equations for position as a function of time, and that is, for ballistic flights, y equals y naught plus v naught t minus 1/2 gt squared. Remember, because we always use a equals negative g for ballistic flight. So we want to find how long it takes to hit the ground. So find the ground is 0. I already said that. Here's our 0, y equals ground. And the initial y then, y naught, is going to be h. And we're going to say it's got an initial velocity v. And when v is less than 0, v naught is less than 0, sorry, initial velocity v naught, that's less than 0, but we're going to add it in because we're using the convention that a positive velocity would mean upward and a negative velocity would mean downward. So this is all okay. Minus 1/2 gt squared. Okay, so now we're going to have to do some quadratic equation solving, right? So we're going to have to say, looks like t equals, and we're just going to do the quadratic equation. So let's do the thing there. Negative b plus or minus square root of b squared minus 4ac all over 2a. And this is where a equals negative 1/2 g, because that's our coefficient on the t squared term. B equals v naught, and c equals h. So plugging all this in gives us t equals negative v naught plus or minus square root of v naught squared minus 4ac. Well, a is minus 1/2, so minus 4 times a minus 1/2 g. It's actually going to be positive 2g, and then we have the h. So v naught squared plus 2gh all over 2 times a. Well, again, a is negative 1/2 g, so this is actually just going to be negative over negative g. So, wow, is this right? I guess so. All over 2a. Huh? Y equals y naught plus, I think this looks okay, so let's keep trying. So this gives us t equals v naught over g plus or minus square root of v naught squared plus 2gh over g. And since this was a negative, but we had the plus or minus there, we can just cancel out the negative in the denominator against the plus or minus, and still plus or minus. So, well, nothing for it but to plug numbers in. So let me plug my numbers in, and my numbers are v naught equals negative 11.2 meters per second. G is, of course, equal to 9.8 meters per second squared, and height is 26.0 meters. So let's see what I get here. This is going to be t equals negative 11.2 over 9.8, and then plus or minus square root of v naught squared. This is going to be 11.2 squared plus 2 times 9.8 times 26 all over 9.8. Well, let me pause for a second and I'll plug this in and tell you what I got. Alright, I'm back. So my answers, I get two answers. I get t equals 1.43 seconds, or I get t equals negative 3.71 seconds. And so if I've done all this correctly, what this means is this is the real answer here, t equals 1.43 seconds. And this other answer here is sort of my phantom second answer that I get. And this covers the case where he actually, let's see, what would it be like? This is how far before this time, or before he released the rock, it would have had to be thrown up from the ground. So this is 1, and then this is sort of a backwards time version, the other. So let me see if this is the correct answer. I'm going to ask WebAssign. And WebAssign tells me that, oh my gosh, I typed in a comma instead of a period, so there we go. And I did get that correct. So then to find the speed of the stone at impact, that's fairly simple. And I can do it up here. I can say V equals, I'll carve out some space up here, V equals V naught minus GT. This is just our ballistic or free fall velocity equation. And so our V naught here was minus 11.2 meters per second minus 9.8, that was our acceleration, times, again, the time was 1.43, just found that. And so that should give me 9.8 times 1.43. And so the answer that gives me is 25.2 meters per second. So let's try that with WebAssign. And 25.2, no, 2, did I get that right? 25.2, yes. And cha-ching, I'm right. So that is our answer there for my numbers.